So now in this video, we are first going to look at one LED here, being protected by 12 volts. We can do that with the 1000 ohm resistor. As you can see with a green LED, it's pretty bright, just like with the blue LED. Also like the blue LED, it builds up about 3 volts across it. It has a forward voltage of about 3 volts, which means that when current's passing through it, it's going to drop about 3 volts from that supply voltage. Ultimately what that means, the resistor will be what sets current. LEDs, they need, the green one's about 3 volts before they will conduct, probably about 2.5 before they conduct a little, but ultimately about 3 volts for it to conduct. And it also builds up that voltage across it. The rest of the voltage goes across a resistor, if that's what you're using to limit current, and that sets the current. At 9 volts divided by 1000 ohms, we have about 9 milliamps of current. And you can see here, power supply says 8. It's not as accurate as a multimeter. And also when it's a spec below 9, so like 8.99, it'll probably say 8 instead of 9, because that's as far down as it goes when it comes to milliamps. So yeah, that's basically what the power supply says. Now, what we can do, we'll take voltage measurements later. We can, take some of the stress off of the resistor and get more light by putting 2 green LEDs in series. But if we want to stay at that 9 milliamps of current right there, we can just use a resistor that's somewhere a little bit higher than 600 ohms. And 680 ohms is a value that I have. That's the main reason why I picked that. And so there you can see. If we wanted 9 milliamps with 6 volts across the resistor right there, we'd want 667 ohms, which that's really close. Perfectly fine for what we're doing. And again, we can get light from 3 LEDs. So each LED is going to produce as much light as this one. We'll look at that later. But altogether, they're going to build up about 3 volts each for a total of 9 volts right there, leaving only about 3 volts across the resistor. Again, 330 ohms is a common value right there. And there you can see 3 volts divided by 0.009 amps will give us the resistance that we desire to get 9 milliamps of current, and 333 ohms. So pretty close to spot on. The common value right there works out really well. And I put a note there that green LEDs typically drop about 3 volts. So do blue volts. VF, big V, little f, means forward voltage. And so when you read a data sheet or something, you'll probably see CVF, but it will probably also say forward voltage somewhere. But next to that VF symbol, if it's like a green LED that you happen to be looking at, or blue LED, then it'll probably say like 3 volts. Now, I don't think I really ever see any data sheets for LEDs though, but there's a lot of components with a forward voltage, and so in those cases you will see that. So now all we're going to measure with the multimeter is voltage. This is auto ranging. If you have one, I bumped the power supply, and that alligator is coming loose. Alligator clip right there. All right. So, in any case, all we're going to measure is voltage. This is auto ranging there. I only have to move the red probe if I'm measuring high current. Otherwise, I leave the probes where we are, and we're not even going to measure the current with the probe. We can see how much current is on the multimeter. So, on the power supply. So there's 12 volts. Looks like we're losing like a spec along the way because there's a little bit of resistance in the wires and stuff. But there you can see 3 volts across the green LED. It's a little shy of 3 volts, so if we went up in current a little bit more, then it would go above 3 volts. It changes a little bit with current right there. Very, very low current, like 2.5 volts, and at like 20 milliamps of current, it would probably be 3.2 volts. But there you can see, we got 9 volts across the resistor, which is what we said before. And there 12, you can see like 8 milliamps. Again, we saw that earlier. This resistor might be quite warm, so I'm not going to dilly-dally too much. So now we're going to get 680, and we're going to go up one more spot right there. And let's move this LED over, and I will pluck or drop another one into this space right there. And again, that should be, we should be getting about twice as much light. That second LED, they should both be about as bright as the one was by itself. There you can see, so 8 again. And it's probably, you know, closer to 9 than 8, but it only goes down to thousandths of a amp on there. So, in any case, let's get right to measuring the voltage. Again, it's still 12 volts, as we saw there. Across the two LEDs, and these are really blinding me, they are really bright. We should have, this is across the LEDs, there we go. Once things stabilize, we should have about 6 volts right there. So again, it's still a little bit shy, and yeah, let's go to that one. So first I'm just going to measure the bottom one right there, 2.94, which I think was exactly the same we saw before, and probably up here as well. Yeah, 2.96. You know, they will vary like slightly. And did we see that? Yeah, 8 milliamps of current. I don't know if I showed that or not. So yeah, that was a 680, which is a blue, and I didn't remember blue. But yeah, they didn't paint these very good, so I can't even really see the color of 8. I didn't memorize 6 or 8. They are not, you know, often use resistor values right there. So did that? Yeah, I believe I'm in the right spot. I have flash spots for the green LEDs. When I looked at the green LEDs. So there we go. Now we got 3. So they're in series. Remember, current's going through all 3 of them equally. And so they're all, again, you know, probably close to 9 milliamps above, but above 8. But 8 is, you know, what we can see there. Probably 8 and a little more. So there we go. Down to about 3 ohms of, or 3 volts, I mean, across the 330 ohm resistor right there. Meaning the rest of the voltage is across the LED. So, series components, the voltages add up. That's something always to remember. And there we go. And about 3 across that one right there. And again, I'm being blinded, so I'm kind of just feeling my way there. So, alright, again, about 3 for the middle one right there. And there we go, about 3 for that one, for a total of 9 volts right there. And there's the current. Now it says 9. We probably, according to the meter, just went from like 8.9 up to 9, and a little, just slightly above 9, probably right there. But yeah, there you can see the 12 volts there. I limited current just in case I short circuit something. If you actually short circuit it, it will cut power. If you just like short circuit the LEDs here, you got a lot of voltage across a 330 ohm resistor. This is going to limit current needed to protect it. That's what that is doing. So I'm going to yank those, and I'm actually going to short it, because we should be fine, because this limits current. Let's get the multimeter out of the way. I'll just demonstrate that really quickly. For those who do not know, I mentioned this in a lot of videos, but I don't usually demonstrate it. So we'll come back, and there's a good jumper to grab. So yeah, when I had the probes, maybe I could accidentally touch that and touch ground somehow, or you know, the ground side of the LED with the pole or something, then current would go around the LEDs. Hopefully that makes sense if I touched it with the probe. But there we go, I stuck a jumper there. It's kind of like a probe that makes a connection from the resistor to something connecting to ground instead of the load. We could put the LEDs back right now, they would turn off, but I'm not going to go that far. So there you can see, we got our 20 milliamp current. When I press that, that's the voltage that it's applying across the resistor right there, like 6.47. So it may be getting, you know, hotter than we want, but not near as hot as if we had 12 volts. Remember, wattage, power, the heat generation, is voltage times current right there. So we got this wattage here. That's what's actually across the resistor. Whereas if we didn't have the lower voltage there, we had this much voltage across the resistor, there'd be a lot more current, and then you multiply those together, so it'd be a lot higher than what we got now. Wattage goes up really quick. You add a little more voltage across the resistor, it adds a little bit more current, but then you multiply those two numbers together, so you got higher voltage and higher current it's a lot more power, more heat that needs to be dissipated. These are quarter watt resistors, by the way, which is typically what you get in a kit. You should stay below 1/8 of a watt. So, in any case, just a little bit review there. And I probably will not be using 12 volts in the next circuit. That's generally given at any time. So I'm going to drop this down to 5 volts. That's kind of what I expect the power supply to be, with the limit of 20 milliamps of current at any time. And if I actually short circuited the two components, it wouldn't just, the two power supplies, it would not output 20 milliamps of current. It would actually turn off. So that's a little tricky thing when you got really low resistances. You want to put current through. This might shut off because it thinks it's a short circuit. But again, simple topic, so I assume it's probably not something that you've dealt with a lot, series components. So I'll throw in some extra info on other stuff related to it while you are powering them and stuff. So hope you enjoyed. Make sure you check out one of the other videos I'm posting on screen, and check out the links down below. They all help out a lot. I will see you in the next video.